single flame can light a million more.
It has been a long Monday today. I'm here to tell you guys what. I have got the coolest build. I've been keeping this in my back pocket now for about 4 months. And the gentleman that bought this box, his name's Jay. And Jay has been through a lot in this last year. Jay called me and he asked me to build him something that we'd never really seen before in the radio world. He wanted me to build a custom memorial to his son, his boy that passed away. And I said I would. So it's time to start. This is going to be a 16-pill Toshiba. Alright. These are all matched transistors. And in the process of talking through with Jay what he wants to actually get done, he wants to do a backlit picture of his boy. Now, what this is here is some vinyl work I have my vinyl do. This is his son. And instead of doing some cheesy in the loving memory, working with him, we talked about this. Jay's actually been here a couple times now. He comes up and I'll spoil him rotten. We'll go eat and we'll go hang out and stuff. And I've just been listening to him about what he wants to have built. And so this isn't going to be the most complex thing I've ever built, but there's been a lot of thought in how we're going to do it. Let me show you. I'm going to start explaining this to you. So normally the cabinet sits like this, where the end of the fenelic here is, this would be the back end of the box. So your air flows in through your 420 millimeter fans, goes across your parts, wraps across your heat sink, and comes out the back. Now I had this board specially made for me just for this build. If you get a 24-pill heatsink from most of the suppliers out there, what you're going to end up getting is heatsink that's got 2 less fins on it than this, and there's going to be a big gap down the middle, and I usually use that gap to run my power wires through. Oh look, there's truck CB sales trying to reach me as I'm shooting this video. I didn't want that. What I wanted this time around was I needed to maximize the amount of surface that the heat could go to. Because once you see how I'm going to put this together, airflow, we're going to still have our standard 120 millimeter fans, but the air is going to have to curl around the sides of what we're going to put on the inside of this deck. And so I wanted to create the most amount of heat sink dissipation as I possibly could lay my hands on. Excuse me. So instead of mounting it, let's say this is the back of the amp where the coax connectors are at, and this is the front where the on-off switch is at, we're not going to mount it like this. We're going to build it backwards, upside down, and inverted. The deck and the heat sink and everything's going to be backwards. It's going to put our relay in here, because I need the rest of this space up here to hold this. We're going to mount it something like this on the inside. That makes sense? So tonight, my goal is to get the transistors down and mounted. I got to get the geometry of this figured out because this is double-sided phenolic board. Cool, right? So what we're going to do is I'm going to acid etch out this. And then what we're going to do is in reverse is we're going to paint this. And then I'll come back with acetone and I'll wipe the paint off. So everywhere that there's copper, which is what's going to be the reverse of this, is going to be dark. Or I might just leave it bare copper. Then underneath we're going to have LEDs to light it up. But on the bottom side, like we're going to picture frame out his face on the back side. So around here we're going to picture frame this out. Then we're going to etch this material away. It's directly behind his face. The rest of this we're going to leave copper because we're going to need to use it. All the nasty little pain in the ass bits that are to put together, the combiners, splitter, and all that crap, instead of it being here where it normally would be, we've got to move it all to here, which is going to be fun. Or as I like to put it, when something challenging comes along, challenging. I mean, most guys would want to get away from this kind of custom build because this is going to take a ton of time. But it's for a good cause. So I don't mind putting it forth. So we're going to have backlit, and then we're going to glow this cabinet blue with LEDs in reverse coming down upon it. So when he turns the box on, his son's face is going to be lit up in white. And I had to go out and get, most of this phenolic actually is tan. See this tan that's on here? This is a white. So son's face is going to be lit up white into a black cabinet. It's got some really kick-ass custom vinyl wrap on the outside of it. But the top of the cabinet, we're going to cut a window on the top of it. So the whole front portion of the box, you're going to be looking down in it. Now we're going to hide everything that makes this box chooch on the back side of it. We're going to utilize this as our ground. So we're going to build it backwards, in the cabinet backwards. We're going to put everything in here upside down. And then on the back side, we're going to build it inversely with itself. So this little bit of real estate is going to get real cluttered. So what I've got to figure out is, do I want to bring my power wires out this way and run them over here? Do I want to run them out this way? This is going to be fun. But guys, that's what I do here. This is what I do. The only easy day was yesterday. Seriously. Gentlemen, my name's BBI. Enjoy the time lapse. I'll see ya. Okay, so let's see, what time is it here? It's 5 to midnight. Let's hold this up here for the time-lapse camera. 1 frame per second. so we can sync these up. Now, I know in the intro I said that I wanted to do backwards, upside down, and inverse, and inverted, and all that shit. I'm sitting here looking at this thing in my head, and I'm looking at it, visualizing this completed in my head. And I had all these delusions of grandeur that I was going to put the relay back here, because this is going to be the back of the amp. Think third dimensionally with me, people. It's okay. So I thought, man, that's going to have to build an elevated platform. Oh, that's an idea too. Build an elevated platform like over here with the splitter. Then I'd have a ton of extra coax. So I could have my input network, and then I got to do my positive rail on top of that, and on top, I'm going to run out of room for my fans. So it hit me. How far back can I take this and still be able to get the picture of his boy at the angle I need? And you know, I got to tell you, I think I'm just going to build this whole cocksucker in reverse. And then take some RG400 and something. Yeah, probably RG400. And just run it straight back to the relays. I look pretty slick. And that'd be a whole lot easier. I mean, how do we want to do this? Pretty slick. So what I want to do is I want to cut this so it sits right at the edge of the fan case. Oh, where's that cabinet? Any 24-pill cabinet will do. Any 24-pill cabinet will do. Got one. Just build two. Here. There we go. Oh, yeah. Okay. I know I already got one of these out someplace. Okay, anyhow. We'll grab one of the extras. Alright. So we're going to be orientated like so. So I've got to get that mural to fit within. Oh damn, it's going to be right at the edge of the fans. Yeah, I'm going to have to build this in reverse. So maybe I black out these two fan holes. I'm going to picture frame this, right? I'm going to picture frame this cabinet up here. We'll make this like out of Lexan, or I want to use plexiglass because it can shatter and this lid's got to be able to flex a little bit, so probably use Lexan. This will fit inside here. Let's see what we got going on. What angle do we got? It'll fit inside of here, like down at this angle. You see what I'm saying? See, this board isn't as thick as the cabinet. Oh hell, hold on. This thing isn't as thick as the actual cabinet. Like I was saying in the intro to this son of a bitch, I went this width for a reason, because now whatever airflow is generated by my fans has either got to flow over the top of this thing and wrap around and come out, or it's got to come around the edges, right? So I wanted to leave myself a good 3/4 of an inch of space, and then we rake it down across the cabinet, so you end up having a vent like this big on both sides. So the air is going to go down and boil out, kind of like if you visualize the air is flowing straight down in somewhat of a tumbleized column, right? And it's going to spin. As it's spinning, it's going to hit the cabinet and roll out. And it kind of rolls the side of the cabinet and then folds back on itself. And that second fold is what we're going to use to cool the combiners and the relay. Coming this way, where in reverse you'd have your combiner and your splitter and the relay circuitry in the back, so they're going to get the fresh air from the curl effect. But then it's going to come up against a low pressure zone, and we want to have, this board's going to be at this angle, right, in the cabinet. So right at the edge of the board, this area in here, you're going to have a low pressure zone, because there's not going to be any reason to have any laminate airflow through that space. And that's where I want to put the warm bits, the tuning tubes, the output, the input tuning circuit, all that in this space here, down on the board. That's going to be tight. But this is what I do. So I can rake it at that angle. It's going to be slicker than titties that are covered in baby oil at the strip club trying to do a wrestling match. That's going to be badass. Yeah, we're talking about trucker titties. We're not talking about strippers' titties. Man. I don't know. It's the other thing I'm kind of playing with. is instead of having this down all the way, kick this up so it's a little bit flatter. And what that buys me is a good finger's width of airflow. So now instead of having the air having to flow down, foil up, and then it runs into the backside of this board, and then it'll have to scooch out and come around the edges, which means you're going to get horrible laminate airflow, but I mean it's going to curl after it comes around. It's going to curl after the air wraps around this edge because there's going to be a low pressure zone here. So it'll curl into itself, and that's what'll cause the airflow to be a little bit more uniform across the heatsink. But then we've got this huge dead space that's underneath here that allow the air to recollimate again. I think I'm going to have to go with a little bit of an elevated lift. So that'll definitely work better. And then if I go with an elevated angle, no, couldn't do it cheesy and just like laser etch his face and put some Lexan behind it. And no, we got to go with a recessed window and make it a little bit tougher because it's just that much cooler. That'll work titties. Oh. have to build a secondary shelf to cut it back at this angle so I don't get any light migration from the fans. I got it. I see what I'm going to do. I see it in my mind's eye, boys and girls. It's like Mr. Jefferson's 32 pill I built here not too long ago, which I've got to build another one of those, by the way. Sitting around a couch and I was eating dinner, and it just came to me the way I wanted to do it. The one with the elevated platform where the combiner and the splitters are all elevated and all the coax is elevated. I see it. I see what I'm going to do in my head. Thank you for joining me on this mental journey process. Later.